Good morning children, welcome to your maths class with Poonam Bagga. We are studying chapter 3, playing with numbers. Up till now in this chapter we have learnt about factors and multiples, and in our previous class we learnt about prime numbers, composite numbers, then we discussed even numbers and odd numbers. Today we will be doing exercise 3.2 and we will be taking up question number 1 to 6. Here's the first question for you. What is the sum of any two odd numbers? We have to take any two odd numbers and then we will check what will be their sum. We know that odd numbers end with 1, 3, 5, 7 or 9. These are the digits at the ones place in case of an odd number. Let us try to add these numbers. We take up any two. If we add these two numbers, we will get 4, which is an even number. If we add these two, it's 8, again an even number. If we add 5 and 7, it's 12, again we are getting an even number. And if we add 7 and 9, it's 16. Also you can try to add 1 and 5. If we add these two numbers, it's 6, again even. 3 plus 7, it's 10, again even. If we add 5 and 9, it's 14. It's again even. Even if you add 1 and 7, it's again 8, an even number. Also if you try to add 3 and 9, it's 12, an even number. So in any case, whenever we are adding any two odd numbers, then we are getting an even number. Even if we take large numbers, then also an odd number will have only these digits at ones place, and so after addition we will get an even number. So we say that the sum of any two odd numbers is an even number. You can write any two examples also. Suppose we add 23 and 51. What will we get? 3 and 1, it's 4 and it's 74. Yes, it is an even number. You can take any other number also. Let us take 11 and 17 suppose. Then it's 7 and 1, 8, 28. So you can take any two odd numbers and every time you will get an even number as the sum. Then what is the sum of any two even numbers? We know that even numbers have the digits 0, 2, 4, 6 or 8 at the ones place. So if we add any two even numbers, suppose we add these two, the sum will be 2, which is an even number. If we add these two, it will be 6, again an even number. If we add these two, it's 6 plus 4, 10, even number. If we add these two, it will be 14, which is again an even number. Even if you add these two numbers, 0 and 4, it will be 4, even. If we add 2 and 6, it's 8, again even. 4 plus 8 is again even, 12. Even if you add 0 and 6, it's 6, even number. If you add 2 and 8, again it's 10, an even number. So in any case, you add any two even numbers, we get an even number. So we can write the sum of any two even numbers is an even number. And you can write any two examples. Suppose we add 32 and 54. What do we get? It's 2 plus 4, 6 and 5 and 3, 8. 86, even number. Then again you can take any other number. 12 plus, suppose we take 18, it's 30, again an even number. So if we add any two odd numbers or any two even numbers, the answer will be an even number. Then we take up the second question. State whether the following statements are true or false. We will read the statements and then we have to examine whether it is a true statement or a false statement. So the sum of three odd numbers is even. Let us again write down the odd numbers, digits that will be there at ones place. In case of an odd number, these will be the digits. If we add these three, it's 5 plus 3, 8 and 1, 9. Is it an even number? No, it's coming out to be an odd number. Even if we add these three odd numbers, 5, 7 and 9, what will be the answer? 9 and 7, it's 16, and 5, it's 21. Again an odd number. So we cannot say that the sum of three odd numbers is even. It is a false statement. You can give the example every time. You can write 5 plus 7 plus 9 is 21. So it's a false statement. You can give other examples also involving large numbers. Then the sum of two odd numbers and one even number is even. Now we know that sum of two odd numbers will be even. We just now discussed in the question number 1. And if we add two even numbers, again even plus even. If we add two even numbers, again it will be an even number, as we just now discussed in question 1. And so this sum will be an even number, and it's true. You can give any example also. If you add 11 and 13 and take up another number, let us take it to be 16. So these two are the odd numbers and this one is an even number. If we add these two, it will be 24 and it's plus 16, it's 40, which is an even number. So yes, the sum of two odd numbers and one even number is even. That's true. So we have written true. The product of three odd numbers is odd. Product means multiplication. Whenever we multiply two or three numbers, then the answer that we get is called the product. So here we take three odd numbers. Let us take 11, then 3, and let us take 7. Three odd numbers, three simple easy odd numbers. We know it's 33, 11 into 3, and if we multiply by 7, we will get 3 7s are 21, 2 carat 23. So what are we getting? Again an odd number. So the product of three odd numbers is odd. That's very much true. You can take one more example. If we multiply any other three odd numbers, let us multiply these three odd numbers, 3, 5 and 7. We know 5 7s is 35, and if we multiply it by 3, what do we get? 3 5s are 15. It will be 105. Yes, again an odd number. So the statement is very much true. Yes, the product of three odd numbers is odd. Then we have some more statements. If an even number is divided by 2, the quotient is always odd. Let us write down the numbers, even numbers. We know 2, 4, 6, 8, 10 and so on. They are even numbers. If we divide by 2, what do we get? If we divide it by 2, we are getting 1, an odd number. If we divide 4 by 2, we get 2, which is an even number. If we divide 6 by 2, we are getting 3, again an odd number. It's odd. It's also odd. And here if we divide 8 by 2, it's 4. It is even. So what do we see? If an even number is divided by 2, the quotient is not always odd. It can be even also. Here you can see this is even, this is even. These two are odd, but these two are even also, na? So we cannot say that always when we will divide an even number by 2, we will get an odd number. We can get odd number also, and we may get even number also. So this statement is false. We can give some examples also. Here we can write, suppose we divide 24 by 2, we are getting 12. Again if we divide 32 by 2, we are getting 16. So these are the cases where the division by 2 is not odd, it is even. So it's a false statement. All prime numbers are odd. We know the list of prime numbers. From where it starts? It starts from the number 2. And is 2 an odd number? No. So we cannot say that all prime numbers are odd. There is one prime number 2 which is even. So we can say here it is false. We need to write here 2 is a prime number which is even. So it's a false statement. We have more statements with us. Prime numbers do not have any factors. It's false. They have two factors. Which are those two factors? 1 and the number itself. So it has two factors, and so this statement is again false. You can say here a prime number has two factors. Which are those two factors? 1 and the number itself. These are the factors of prime numbers. Okay, then sum of two prime numbers is always even. Let us write down the prime numbers first. We have 2, 3, 5, 7, 11, 13 and many more. Now let us try to add any two prime numbers. If we add 2 and 3, what do we get? 5. Is it even? No, it's not even, it's odd. If we add 2 and 5, we get 7. Again an odd number. So every time we can't say that the sum will be even. If we add 5 and 7, then of course we are getting even number 12. But not always we get an even number. हर बार जब हम दो प्राइम नंबर्स ऐड कर रहे हैं तो हर बार हमें इवन नंबर नहीं मिल रहा है. यहाँ पर हमें 5 मिला, यहाँ हमें 7 मिला 2 और 5 ऐड करने से. सो दिस इज अगेन अ फॉल्स स्टेटमेंट. इट्स नॉट ऑलवेज. It may be even, it may be odd also. Then we have 2 is the only even prime number. That's true. We know that except 2, all the other prime numbers are odd. And so this is a true statement. All even numbers are composite numbers. Yes, even numbers are multiples of 2, we know that. But all are not composite. We know that 2 is an even number which is a prime number. And so we cannot conclude this for all even numbers. And so we take it as a false statement. 2 is an even prime number. Here you need to mention it. And so this is a false statement. Even though there is only one even number which is prime, but still this statement we cannot say it true, it is false. The product of two even numbers is always even. Let us try to multiply any two even numbers. We know that the even numbers have these digits 2, 4, 6, 8 or 0 at ones place. If we multiply 2 and 4, what do we get? It's 8 on multiplication. It's even. If we multiply 4 and 6, we get 24, again even. 6 8s are 48, even. 8 10s are 80, again it's even. So whenever we are multiplying two even numbers, we are getting an even number, and so it's true. You can see other numbers also. If you multiply 2 and 6, it will be 12 on multiplication, even number. If we multiply 4 and 8, it's 32, even number. And similarly you can try to multiply any two even numbers, you will get an even number. So it's a true statement. Then we have this question. The numbers 13 and 31 are prime numbers. You can see both these numbers have same digits 1 and 3. Yes, here also we have 1 and 3. Here also we have 1 and 3. Find such pairs of prime numbers up to 100. What is special here is the two digits are interchanging. First we are having 1 3, then we are having 3 1. So we have to look for other such prime numbers which have the same digits, but after interchanging we get the same prime number. we have the same digits and it is a prime number, and after interchanging also we get a prime number. So we are looking for such numbers. For this we need to know the prime numbers up to 100. We had discussed it in our previous video. We can write them once again. Prime numbers from 1 to 100. Let us write them. We started from 2, 3, 5, 7, 11, 13. Then we have 17, 19, 23, 29. Then we have 31, 37, 41, 43, 47, 53, 59, 61, 67. Then we have 71, 73, 79, 83, 89 and 97. So these were the prime numbers up to 100, from 1 to 100. What we are looking for is, we have to find such numbers which on interchanging the digits, when we interchange them, again we get a prime number. So these are single digit numbers, so we will not take them. We start from 11. We know after interchanging also we will get 11, so it is again not of any use for us here. Then 13 has already been given in our question, so we will not take it. We start from 17. We have this number 17, and if we interchange its digits, we will get 71. Again, is 71 a prime number? You can see that yes, 71 is again a prime number. So this is one pair in which both the numbers are prime even if we interchange the digits. So we got this one pair. Now we are looking for other such pairs. We have this number 19. If we interchange, it will become 91. Is 91 a prime number? Is it there? No. 91 is not a prime number. It has factors 1, then 7 also, 13, 91 itself, and so it's not a prime number. So this is not satisfying our condition that both the numbers should be prime, and so we remove this. Then we take up the next number 23. If we interchange the two digits, we will get 32, but 32 is an even number and it is not a prime number, so again it will not help us. We come on to 29. If we interchange, we get 92, which is an even number, and so it is not a prime number. 31 we have already taken along with 13. In the question it is given 37. If we interchange, it becomes 73. Is 73 a prime number? Yes, you can see it here. Yes, these two numbers are prime numbers even if we interchange the digits, and so this is one such pair that has been asked. Then what next? We move on to 41. If we interchange the digits, it's 14. Again it will be an even number, and then it's a composite number, not prime, so we will not take it. Move on to 43. If we interchange, it will become 34, an even number, which is again not a prime number. We move on to 47. On interchanging, it becomes 74. Again, it's an even number and then it will not be prime. 53. If we interchange, it will become 35, and 35 is a composite number. It has more than two factors. It comes in the table of 5 and 7, so it's not prime. 59. If we interchange, it becomes 95, and 95 is a multiple of 5, so it will have more than two factors. It's not prime. 61. If we interchange, it becomes 16. Yes, a composite number, not a prime. Then we have 67, and if we interchange, it becomes 76, which is again even, and it will not be a prime number. Then we have 79, and if we interchange it, what do we get? It becomes 97. And is 97 also a prime number? Yes, it's a prime number. So we get the third pair in this form. 79 is a prime number, and on interchanging 97 again is a prime number. So we have these three pairs. 38 on interchanging 8 and 3 we get 38, which is even, it will not be prime. And again on interchanging 89, 8 and 9 we will get 98, which will be even, and it will again not be a prime number. So we have these three pairs, such pairs of prime numbers in which even on interchanging we get the prime number. Then what next we have is, write down separately the prime and composite numbers less than 20. We have to write the prime numbers less than 20. We can write them easily. We know it starts from 2, then we have 3, then we have 5, then 7, 11, 13, 17, 19. So these are the prime numbers less than 20. You can have a look here also. Prime numbers less than 20. We started from 2 and here till 19. Less than 20 we are taking. Then what next we have to do? The composite numbers less than 20. Obviously 1 is neither prime nor composite, so it will not be there in any of these two lists. Then we start from 4. 2 and 3 are prime, 4 is composite, 5 is again prime, 6 is composite, 7 is prime, 8 is composite, 9 again, 10, then 11 is prime, 12 is composite, 13 is prime, and then 14 is composite, 15, 16, 17 is prime, and 18 is composite. And we have to take less than 20, so 20 will not be included. So here till 18, these are the composite numbers and these are the prime numbers less than 20. Then we have the next question. What is the greatest prime number between 1 and 10? Let us write down the prime numbers between 1 and 10. They are 2, 3, 5, 7. That's all. 4 prime numbers between 1 and 10. And out of these, which is the greatest? You know, 7 is the greatest of these. Greatest of them is 7. It's an easy one. Then we have question number 6. Express the following as the sum of two odd primes. Here this number 44 has been given and we have to divide it or break it into two numbers, one number and second number, such that we have to add these two numbers and get 44 back. So we need to break 44 into two odd prime numbers, odd primes, such that we get 44 back. For this we need to know the list of prime numbers. We have this one. These are the prime numbers from 1 to 100. We will be looking for numbers in which we can break 44. Let us take one by one all these numbers we will analyze. If we take 2, 2 is even. We have to take both the numbers odd primes, remember. So we will not take 2. This we will cancel. If we take the first number as 3, then what will be the second number? We can get this by subtracting 3 from 44. It will be 41. Is this 41 a prime number? Yes, it's there. So we can write it in this way. 44 can be broken up in this way as the sum of two odd prime numbers. दो ऑड प्राइम नंबर्स के फॉर्म में हमने इसको ब्रेक कर दिया है. एक अगर हम 3 लेते हैं तो दूसरा हमारा 44 माइनस 3 करने से 41 मिल गया, तो इन दोनों का सम हमारा 44 हो गया. इसी तरह से एक और ले सकते हैं. इफ़ वी टेक दिस नंबर एज 5, देन देयर सम विल बी, if we take 44 minus 5, what will we get? 14 minus 5, it's 9, and 39. Is this 39 also a prime number? No, 39 is not a prime number. So this is not the pair that we are looking for. We need both the numbers to be prime. If we take 7 as one of the numbers, Then what will be the second number? We will subtract 7 from it. 14 minus 7, it's 7 and it's 37. Is it a prime number? Yes. So we get this pair as sum 44. In this way you can get many more pairs. Randomly also, if we add 31 and 13, you will get 44. So we are writing 2 or 3, but we have been asked only 1. Express as the sum. We have been asked only 1 pair. I have written 3. You can take any other also. Then we have to break this 36 also in 2 ways. Again, if we take the first one as 3, then the second one will be obviously 33. But 33 is not a prime number. So we will cancel it. We take the first number, suppose, as 5. Then the other one will be 31. Yes. Now the two numbers are prime, odd, and their sum is coming up to be 36. We can find other such pairs also. We can take, suppose if we take 7, then it's 29. Again, both the numbers are prime and their sum is coming out to be 36. We have 2 more such numbers. 24. Again, we need to break this 24. If we take the first one as 3, then the second one will be 21. But this 21 is not a prime number, so we will not take it. Then what we will do? We take some other numbers. If we take 5 as the one number, then we have 19 plus 5. Yes, both of these are prime and their sum is coming out to be 24. Similarly, you can search for other such pairs. Now we move on to 26. We have to again break this 26. If I take one of the numbers to be 3, then the other one will be 23. Yes, both are prime numbers and odd numbers and their sum is coming out to be 26. Similarly, you can search for other such pairs such that their sum comes out to be 26 or 24. With this, question number 6 is complete. In our next class, we will be taking up question number 7 to 12 of exercise 3.2. Thank you.